Hello everyone, this is Adam Vig, and in this video I would like to introduce you how I created the seat utilization part of my Maven Pizza challenge and trip. So we are talking about this utilization table. This table describes that in average how much occupied the seats and the tables in the pizzeria in the different days of the week and in the different hour buckets. So that's what we will create, and let's get started. Let's start with a brief overview of the data model, what we have. So if I go to the model view, what you can see here's how my model looks like. So here we have the order details, that is detailing how many pizzas we have sold. It's connected to the orders. That shows that when the order has made by the date and the time. That is connected to a calendar table. And also we have dimension table for the pizzas that contains, it's actually a consolidated dimension table that contains the pizza name, the category, the size, and the price of the pizza, and everything that is the dimension of the pizzas. Also, we have an ingredient table, but this is something that we will not use on this visualization. The next step now is to create the hour bucket table that is showing us that which is the hour bucket that you would like to say how occupied that hour bucket is. For that, we should go back to the transform data, and within the transform data, we will create it manually. So actually, we can use the enter data here to create a new table, and the table name will be our bucket. And here, this is actually a manual task to create the hours, create the hour bucket column. Now I'll just copying it there. So we will have an hour bucket. We will have a start hour, and we will have an end hour of that bucket. So we have this bucket that starts here and ends here. Okay, so you just need to manually type it as I've just copied it over to it. The name of the table will be our bucket, and then just click OK. It creates us the table, so you can see here, and then we can load it to our data model. Once it's loading very easily. Actually, the table itself should be a standalone table. Okay, so we don't connect it to any other tables, even for the calendar or for the fact tables. It should be a standalone table, and we will create the connections and the relationship to the transactional data by the DEX measure itself. One thing that we need to do that instead of having the starter and NDR, we will create start time and end time, and that's how we will bucketing the orders in these our buckets. So I've created a new column within the table that will read the start time, and it's very easy to add the time function. Hour is the start hour, then 0, 0, and it's date time, but it will be just the time. And we will do the same for the end time. It's time, end time, and hours, sorry, 0, 0. And we also set it as an end date. Okay, so here we have the hour bucket, and we know that when it starts and when it ends. And then we can start creating the measure to put different orders into those buckets. In the next step, we need to define the likely number of guests. For that, we will be using a logic that is based on the pizza size. So we assume that for the smaller pizzas are for just one person, and the bigger ones are for several people. For that, we will be using the size of the pizzas. That if we check it out, you can see it's S, M, L, XL. Sometimes there are XL and XXL pizzas, and we will be using those size for the logic. However, we also need the quantities, right? That on the sales order details, if we have like 3 person is eating one XL pizza, but there are 2 pizzas ordered, definitely that will be 6 person in total. So we need to define the logic on the order details level. We can also do it on the pizzas to create that what is like number of guests per pizza, and then we can create a logic that is multiplying it by the quantity on the order detail. But now I will just do it in one step. Okay, so I create a new calculated column here in the order detail that will call like the number of guests. And first, what I will do is that I'm using a switch function to decide on if the related size is the size is in, let's say, S or M. For those sizes, there's 1 person eating them. Okay. If the size is L, then it's eaten by 2 people. If the size is XL, then it's 3. The 1 comma is missing. In all the other cases like XXL, XXL, I'm just using this is for 4 people in general. Okay, so this is defining that a specific pizza is how many people is likely to eat that specific pizza, and here we need to multiply it with the quantity of the pizzas ordered on that line. Okay, so we have it. Okay, so we now have the likely number of guests. What I would like to have is the hour bucket. So let me start to put it there. Here is the hour bucket. We can make it in a different, no, so it's not yet, yeah, it's not yet sorted. We can sort it. So the hour bucket, we can sort it by the start hour, for example, and in this case we can see the proper order. So it's starting from 9 a.m., 10, 11, and here it shows all the buckets until the very end at the closing date. I'd like to have a matrix, and in the columns I want to have the weekdays. So here the weekdays in columns. And yeah, it's not good because we don't have any measures there. First of all, let me put the quantity there. What we can see here, what can we see here? Here it shows all the orders for Fridays, Mondays, Saturdays, Sundays. So it seems that the weekdays are properly filtered. However, we don't have any filters on the hour buckets. And also for the weekdays, we have a lot of weekdays there. So we definitely just need an average for the days. And we also need to specify another filter with a measure that is specifying that what is the hour bucket and which orders should be calculated for that hour bucket. First of all, we need to create another assumption. And this assumption defines that how much time somebody spent in the restaurant. Okay, so to count the orders or count the number of guests who are in the restaurant in that specific hour bucket, we already have one information, that is the order time. With the order time, we know that when the order has been taken, so we can assume that this is the start date when somebody just sitting to the table, next to the table, and asking for their pizzas. But we also need to know that how much time they spend in the restaurant. So this is also an assumption. If this is a quick restaurant, maybe this is just 40 minutes in average, but if this is a gourmet pizza, for example, then it can take much long. So just for this exercise, I will use 90 minutes So I will assume that if somebody go there, sit down with the family, they will spend 1.5 hours. Maybe this is too long, yeah, but I will just use it for this example. So for that, within the order header, when there's the order time, I will create a new calculation that is the expected leave time, assuming that 1.5 hours of stay, and this will create a calculation that if the order time plus, I'm adding this time, 1.5 hours, seconds. First of all, I need to check if this time is over the close time. So it's the time of 3:00. So if this is exceeding the order, the closing time, then I am using the closing time for the leave date because yeah, they are eating for 10 minutes, but if the restaurant closed, the restaurant closes. Otherwise, I will use the same order time plus this 1.5 hours of stay. So if I check this in a table format, you will see here that this is the order time, and here we have this new column. We need to change it to time, and it will show us that if somebody sits there in 11 a.m., then it will probably leave a little bit after 1 p.m. Then our next task is to create the measure itself. With that, we can count all of the orders and all of the guests who were in the restaurant in the specific time frames. Okay, so for that, we will create a new measure, and this measure will be the likely number of guests by our bucket. And in this measure, we will calculate that in which hours how many guests were in the restaurant at that time. So for that, I will create an all guests variable. And in this variable, we will calculate the sum of the likely number of guests that we calculated in the previous step. And then we will create the filtering to count only those ones that are in the specific hour. Okay, so first of all, we are calculating all orders, and then we will do actually a few different filters that make sure that in all buckets we are counting the right number of guests. Okay, so basically there will be three different rules. The first rule will be when the order time is within the hour bucket, and for that it's calculating the start time and the order time is less than the end time. Okay, so this one is calculating all of the orders where the order time is within that specific hour bucket. Okay, we will do the same. So, or we would like to also count those ones where the end time, so the expected leave time that we just calculated before, is also within that hour bucket. Okay. In this way, we will capture all of those ones where the expected leave time is within the hour bucket. And we have one other one when some somebody is staying there, 1.5 hours. So let's just imagine that they arrive to the restaurant at hour 50 and then leave in hour 10 minutes after the full hour. So there's an entire hour that's staying in the restaurant, and the start date is before that hour and the end date is after that hour. So we will capture that one. So it means that the order time is less than the start time of the hour bucket, and the order time, the expected lead time is higher than the end time of the specific hour bucket. Okay, so with those three um, filters, we are assigning the stay of the guests in the different hour buckets, and we need one more filter here because here we released all orders. So what we still need to do is that we need to make sure that we are just calculating the orders for the specific weekdays. That is the other dimension of the visualization. So here we are calculating the weekday of the order date. Now the format, and we are saying that it should be equal to the selected weekday of the calendar that is in the x-axis of the matrix. Okay, we are closing it, and in the return, let's just start looking at this order calculation. What you can see here that if I remove the total quantity and if I pull it here, it looks good for us. So the numbers are different, and it's really calculating how many orders were in the different hour buckets. However, it's still very high. It's still very high because it's still calculating all the Fridays during the year, all the Mondays, all the Saturdays, and etc., etc., etc. So what we need to do is to calculate that how many days we had altogether for that weekdays during the year. For simplicity, now I'm counting the calendar. Definitely here we can consider that not all the days the restaurant was open. So we can also calculate, for example, a distinct count on the order dates. But for simplicity now I'm calculating the calendars, and then the measure itself will divide this all guests with the number of days. And it looks like this is the good thing. So it shows that how many guests we had in the restaurant in those specific days. And one more thing that I will do here. So here you can see that the weekday is currently not in order. So to make sure that this is in order, I will sort it by the day of week. So now it's just Sunday, Monday, Tuesday, Wednesday, and everything is in the right order. We have the measure for the number of guests, and we need one more measure that is measuring the number of tables. So for the number of tables, I will use another measure. So here we are not calculating the right number of guests, but we are just calculating the number of orders think we haven't created this measure yet, but we can do it very quickly. Number of orders is just measuring that how many different orders we had altogether. And we are assuming that within one order, okay, so again, I'm creating the measure again. So we are assuming that the guests from one order are sitting to one table. Definitely, it also can be more consolidated that, okay, if there is a very big group coming in, one table is probably not enough, but here just use this one, and this is calculating that. Okay, of course, this number of tables, so it's calculating that how many tables are needed at specific hour bucket in a specific day. Okay, I can also add it to the measure, I mean to the visual here. So now I have this, I can make it a little bit easier to understand. So these are the seats here, and these are the tables here, and now I have the full matrix that shows by days and by hour buckets that how many seats and tables are needed. For that, definitely I can add a 0 also to format it in the same way. What I can also do is that I will remove the totals, and here I have the matrix that shows me the right things. And the last step for us is the conditional formatting. So what we would like to do is to also create a heat map on this, and showing that where this is close to the limit. So we know that the seat limit for the restaurant was 60, and the table limit for the restaurant was 15. And we would like to show that where this is exceeding it, or where this is close to the limit. So here at the seats, we can add the conditional formatting. I will use the background color, and I will use the number of guests by hour, but I will create a rule instead. Okay, here this is a number, and we will say that if this is higher than 60, let's just use 1000, just you can whatever number here, then it's red. If this is, let's say, above 55, below 60, so this is a number, then we should need to know that this is like something very close. And let's say another one that above 50 and below 55. Then we also would like to see that this is something that is close. Okay, close to that. Let's do something rather like this. The same for the tables. So here also we are using a rule, and for the tables we will be using the 15 as a number, and 1000 here, that should be the red, and let's say just above 13 and below 15 it should be this orange. Okay, and now we have this color coding, and this is showing that where we are above the limit is showing it as by red, and showing that where we are close to the target. And that's it. That's how the seeds are created for the R bucket, and that's how the heat map is created for the ones where we are above the specific limits.